I hope that everybody can hear me. Just going to check if this is connected properly, real quick, and we can start it. Okay. Yeah. I think we are streaming live. Yes. Okay. Yeah, we're streaming live. So, hi guys. This is Vinayak Rajagopalan. I am a tokenomics expert with Spark Out Tech, and today we are going to be, we have a small webinar for you guys about smart contracts. So, we've every week on CodeSpot, we've been interacting with you and presenting certain topics related to technology, and so far you've been looking at a lot of things other than blockchain. So today, I think since blockchain is the hot topic right now, and since the crypto market is quite booming at the moment, I think it's fair enough that we start off with something related to blockchain, and more specifically, smart contracts. So I have a small presentation for you guys here, and yeah, so we'll jump right into it. And basically, our topic for the day is the trustless world of smart contracts. So this is the agenda for today. And when you hear the word trustless, what exactly does comes to mind? What exactly does come to mind? Like the word trustless, it is kind of misleading in ways. The word trustless, because isn't trust a good thing generally? Like when it comes to businesses, or when it comes to technology as a whole, if two people or if two entities have to work together, there has to be some kind of trust involved. So, what does trustless mean? The word kind of seems like there is no trust, but that is not exactly what it means, and in ways, that is exactly what it means. So, you will understand better when we get into the presentation, and let's jump right into it. So, what are smart contracts? To understand trustless, what trustless means, you need to understand what a smart contract is. So there are three things that you need to understand when learning about smart contracts. Number one, it is an automated computer program. It's just a software. It's a piece of software, and you code certain things in, certain functions in, and it works automatically, which means that with minimum human interaction, it can work. It runs on the blockchain network. Obviously, a smart contract runs on the blockchain network, self executes based on predefined criteria, and this is what sets it apart from everything else. It is an automated program, and it runs on the blockchain network. So that means that you don't have to do anything to make it work. You just have to deploy it on the blockchain, and it's going to start working if it is coded correctly. That's it. And the other thing is that since it runs on the blockchain network, nobody can nobody can change it, or nobody can edit it. And once it's on the blockchain, it's there forever. So that's why developers take a lot of time when they code the smart contracts, because one, if they get it wrong, it's going to be there forever, and if they want to edit it, they can't. So they have to create an entirely new smart contract to make it work. So that we know. So since it runs on the blockchain network, it is very secure. So if for example, if you want to use it for an enterprise application, so if there's a company and you want to employ certain pieces of code that does certain things, you can easily use it, and you can be sure that nobody can tamper with it. So that's one thing. And the self executing based on predefined criteria is what sets smart contracts apart from everything else, because every contract will have certain criteria, no matter what the contract is. Those criteria are supposed to be carried out by the people who engage in the interaction that is based on the contract. So, but in a general sense, that doesn't happen always. Like if two companies, or even two people, even if two friends are in an agreement, they come to an agreement that they create a contract, that one person does something, the other person returns something in, as a result. And there is no governing factor, there is no governing system that makes sure that these two people do these things like they do as they have committed to. So that is where smart contracts come in. So to understand this better, I think I'll introduce. I mean, I'll narrate a story. So this is Dave. This is my good friend Dave, and Dave is he works at a company. He works at a tech firm, or any company. Dave can be anybody, by the way. Dave is a representation of everybody. So this is Dave, and this is Dave's boss, and this is Dave's company. So Dave is an extremely hard worker. Okay, he has been in this company for a long while, and he's a great worker. He's dedicated to his work, and he works towards the growth of the company. And obviously, his boss, the person in charge, is going to give him the salary for what he's working on, and his boss pays his salary through the company. So that happens in sort, it's kind of like a system that happens. So lately Dave has encountered a situation where he is working overtime, and he's kind of finding it hard to make ends meet, because he's working 16 hours a day, and he's not getting any sleep, he's not getting any rest, and he's getting the same pay also. So what is Dave supposed to do? Obviously he's going to ask his boss for like overtime pay or something like that, but he says no. He then, after that's a failure, what does Dave do? Dave goes to his company, his HR or whatever. They also say no. They say that we can't pay you for the overtime. So what happens here is that Dave is very unhappy, because he's working there, and he's sweating it out for his company, and he's not getting anything in return apart from his general salary. So when Dave joined the company, he had an agreement, like he might have had a contract with the company that he will work for the company, and the company will pay a certain amount of money for his services. And Dave had a trust with the company that the company will give him money when they receive his work, and the company also trusts Dave to do his best for the money that they give. But when this happens, when Dave is not getting what he is owed from the company, then the trust is lost. Then what would happen is, Dave might not do his job properly. The company might threaten him, if you don't do your job properly, we're going to fire you. And overall, there is certain lack of trust between the company and Dave. I know that many of you are working individuals and you can relate to this. I hope that you cannot relate to this in this direct situation, in this analogy, but I'm sure that most of you work in some kind of an employment situation, or you guys are students and you have these situations in colleges or schools or something like that, where you have an agreement with another party, and they when they don't fulfill it, you don't trust them anymore. So this is the centralized system. The centralized system is deeply flawed because it relies on a centralized party. Now, the decentralized system is a little different from this, because trust is always important. If you want to, even if you are transacting some money with somebody else, trust is one of the most important things that you need to have. Even if it's somebody that you have to have trust between each other so that you can transact money or anything else for that matter. So in a decentralized system, what happens is the centralized authority does not exist. It is it is replaced by smart contracts. Now, smart contracts we talked about. It is those are automated computer software systems, like automated programs that work on, like they that execute themselves on a certain pre-described criteria. So what here, like over here, what happens is Dave does his duties, Dave does his work, and he gives them to the smart contract. He completes his work. What happens is the smart contract already has a described like a criteria within the smart contract that if Dave completes these set of works and if he is doing overtime, then he has to be paid this amount of money. That is what a smart contract does. So when Dave gives his work to the smart contract, the smart contract automatically pays him the money. There is nothing the company or his boss or anybody else can do to stop that payment as long as Dave has completed his duties. So that criteria will be hard coded in the smart contract. And this is how smart contracts work. And this is just a small example of a world of opportunities that smart contracts and blockchain provides to us as people. Because this system does not rely on trust. Trust is a very important thing when it comes to transactions, as we said before, not only with financial transactions, but even with like data transactions, anything and everything that we have in our lives that we transact within somebody, that we exchange with somebody, there is trust involved. Any relationship has trust involved. So, but with smart contracts, the need for trust is not there anymore. I mean, at least to a certain extent, it is reduced. Like Dave doesn't have to trust his company that they will pay him because he knows that the smart contract is already built in a way that he's going to get the money if he works for it. Dave doesn't have to trust his boss. No matter what his boss does, he's always going to get his salary on time. So obviously, Dave is happy. And this brings the trustless environment into play. So this is what trustless means. Like I said before, like in the beginning, trustless doesn't exactly mean that you don't trust somebody. It just means that you have eliminated the factor of trust from everything, like from the interactions. So in this case, Dave doesn't have to trust anybody. The company has doesn't have to trust Dave. As long as he does his work, he's gonna get paid. As long as he gets paid, he's gonna do his work. So the need for trust is eliminated, which means that it is somewhat seamless. What happens? You don't have to have any people involved in the money processing in that process. You don't have to have there is not going to be any bureaucracy in this. You can understand why trustless systems are so important because if you look at even the government, for example, the government is highly centralized. The government is a great example for what a centralized system is. So I'm sure no matter where you are in the world, in what part of the world you are, the government, you going to a government office is not going to be an easy task. You're going to have to spend a lot of time there. You're going to have to talk to a lot of people and things like that. So there we as people have no choice but to give in to the centralized system. We have to depend on certain parties, certain centralized parties, and there is going to be a hierarchy of people and officials there, and we have to go to each and every one of them before we can get a task done. With the trustless systems, all you need is a set of smart contracts, and these smart contracts work well together, and they get the task done faster without the requirement for trust. So in a way, by eliminating the need for trust, we are enforcing trust on top of that system. Like if I am a person, if you're a person, and there is a trustless system, if we don't have to trust that system, then in a way we can gladly work with it. We can easily work with that system because we don't need to trust it. In a way, it is easier to trust it. So the use cases, the next thing that we're not going to go in a chronological order of the topics that I've put in. I think it's better this way because it's going to be easier to understand. So so the use cases. When it comes to the use cases, What do you think about when you think about blockchain and cryptocurrencies? Bitcoin, right? Obviously, when almost every single person has heard of Bitcoin. If you're watching this video, you have heard about blockchain or Bitcoin at least once somewhere. So yeah. So what comes to mind when you think of Bitcoin? Exactly. Obviously, money. You think about money because Bitcoin is a currency that it's a cryptocurrency. That's what we are told, and it's expensive fairly right now. So if you bought Bitcoins maybe a couple of years back, you would have been quite wealthy right now. So it's about money, and it is largely about money. What Bitcoin is doing, but what it has also facilitated is peer-to-peer transactions. And to understand peer-to-peer better, we have a story as well. It's an analogy that we have. Okay, so let's say that this is Julie. This is my good friend Julie, and this is my good friend Brian. So Julie and Brian are my friends, and they know each other as well. Okay, and they are like they are their interactions in the monetary sense is governed by the central bank, because Julie and Brian, they work together, and they often go for lunch together, and somebody pays them back. I know that many of us do that. So you Google Pay or Phone Pay or whatever the app you use, and everybody eats, somebody pays, and we divide it among each other. That's a normal thing that we do. But the payment in this case of Julie and Brian is governed by a central authority, which is the bank. So let's say that Julie has an amount of money that she wants to send Dave. She can do that by initiating the transaction, which means that the money goes from Julie's wallet, from Julie's bank account to the bank, and the bank validates that transaction, just like how a transaction mining occurs in blockchains. Okay, the bank validates that transaction, and the bank then credits that amount to Brian. Now they're both happy. But let's just say that since the bank is the central authority, let's just think of a situation where Julie has sent the money to Brian, and he had Brian, like the bank has withheld the amounts. Let's say for some odd reason, the bank decides to not release the money, like soon. Maybe their servers are busy, maybe there is some kind of issues happening within the network or something like that, and the bank is not releasing the money to Brian. Now both of them are really in trouble because Julie has sent the money, she knows that, so it is her money that she has sent, and it is with the bank. She can't withdraw it because the bank has control over the money. Brian needs the money because he spent it before, and he's not getting the money either because the bank has withheld. So whom does that money belong to exactly? It belongs to Julie, but she can't withdraw it. It also belongs to Brian, but he can't withdraw it either. So this is kind of a situation that most of us have faced at a certain point, not just with banks, but maybe because with e-commerce sites or whatever like that, there is a central authority at play there which governs. I mean, that governs everything. So with Bitcoin, the difference is that the central authority is completely replaced with the Bitcoin network. Now, the good thing about the Bitcoin network is that nobody controls it. Nobody controls it. Nobody even knows who made it. A person named Satoshi Nakamoto. We don't know if he's a person or a group of people yet. So they published a white paper, which is a document which outlines certain things about the project. And the project was called Bitcoin. And it outlined a peer-to-peer currency system where there is no central authority, there is no bank, where people can transact with each other. Like when we are going, like just when we are going out with our friends, and we are getting a bite to eat, and somebody pays, and we pay in cash, right? We pay in cash, and that is easy. That is peer to peer. We directly pay them. We don't have to depend on any other central authority to do that. But with Bitcoin, I mean, with banks, you do have to rely on somebody else. Bitcoin eliminates this completely by allowing people to transact with each other through a peer to peer network. Now, we all deal with digital money every day. Every time we use an app to send money, every time we use internet banking or anything like that, we are actually, what we're actually doing is we are transacting with digital money. The difference between regular digital money like the US dollar, the euro, or INR is the how the network works. Basically, how the network works. Now, in this situation that we looked at before, the central bank is the one that governs everything. Here, Julie has sent some money to the bank. The bank has to validate it and store it on their server. They have to store it on their server. That is a normal thing. Bank has to send Brian the money, and they have to like validate that transaction as well. So that Julie has paid the bank has paid Brian. That has to be stored and that has to be validated on their server. What happens is this server is actually controlled by the bank. So what they can do is, I'm not saying that any banks actually do this, but this is actually one of the problems that digital currency faced in its early days. Like when it comes to dollars and INR, it is fairly controlled, so it's kind of different. But apart from that, other digital currencies, because there were digital currencies before Bitcoin, and the reason they failed was because let's just say that a central authority has this. Let's just say that 1,000 coins if I am the central authority, I have 1,000 coins in my hand on my server. Since I control the server, I can multiply that by 2 and turn that into 2,000. So this can happen multiple times. Obviously, if you make multiple like greater transactions with this, like you multiply it a lot of times, people are going to understand that this is something bad is happening. But apart from that, if it is in smaller, if it's in small amounts, nobody is really going to notice until it's too late. So this was one of the problems that digital currency in its early days faced. What Bitcoin did was that it, instead of storing it on a centralized server, it stored these transactions on multiple servers. It's a distributed server. If I transact with somebody else, it doesn't mean that a server nearby to my place stores this transaction records. It can be on another part of the world, on another computer even. And even then, it is not quite secure because it's just a server. So what they did was they brought cryptography into the mix. And with cryptography, and that is actually a discussion for on that time, but with cryptography, what happens is each of these servers, if there happens 100 transactions, 100 of these transactions are going to be stored on different ledgers, like different servers. Let's just say that, and each server is going to have a copy of the transaction of its previous server. It's not exactly a copy, it is actually more of a verification method that it has, because if there is a copy of everything on every server, obviously it's going to be a, there is going to be a storage issue. But it's more like every server can validate its previous server with the data that it has already. It uses cryptography and something called a cryptographic hash function to do this. So that just means that if somebody changes something on the network, all other people, all other all of the peers on the network are going to get notified. All of the nodes are going to get notified. So it becomes extremely impractical to hinder such a network, to hinder such a network. So Bitcoin solved that problem basically. But even Bitcoin only deals with money. It is nobody controls it, so anybody can transact with anybody. So that basically means that everybody can transact with anybody without any kind of hindrance, and that is what decentralization means. So in a decentralized ecosystem, there is a certain level of control that the people enjoy instead of only a few people. Like if you look at governments or banks or something like that, each of them have their own regulations and things like that that people have to accept one way or another if they want to use their services. But with Bitcoin, anybody can transact with each other. But even Bitcoin only deals with payments. You can't really do anything else with Bitcoin. You can, invest in it and gain money. You can send it to other people as payments. But apart from that, you can't really do anything with Bitcoin. So money is basically what Bitcoin on itself is related to. But in 2015, something exciting happened because Vitalik Buterin, he was a young visionary, originally from Russia, but he's Canadian right now. And Vitalik Buterin, Dr. Gavin Wood, and Charles Hoskinson. Three of these people founded Ethereum. Now, Ethereum changed the game when it comes to, you know, blockchains, because the Bitcoin blockchain is considered as a like a generation one blockchain. It's the first generation of blockchains. Ethereum is the second generation of blockchains, because while Ethereum was just about payments and peer-to-peer connections and peer-to-peer transactions, Ethereum is quite a different kind of platform. While Bitcoin was about money, Ethereum meant that people could send money, people could send data, which is a big thing, because if you could only send money, you can only do payments. But if you can send data as well, then you basically have unlimited possibilities. And obviously, connected to data, it is the smart contracts. So when it comes to the use cases of smart contracts, we can see that these are just a few examples of the use cases, like in banking, insurance, and things like that. We got a little sidetracked with Bitcoin. Sorry about that, guys, but I hope that you understood why I had to explain that, and why smart contracts are so secure, because it functions on the same principles as Bitcoin, but you can also create data related applications, and basically applications, decentralized applications on using smart contracts. So these are some of the use cases of smart contracts that we can see, but these are just, I just took an arbitrary number of use cases, because the reality of the matter is that you can have infinite number of use cases for smart contracts and blockchains. Because, for example, if we take banking, you already saw that peer-to-peer systems can be developed, like even deposits and withdrawals. You don't have to depend on the bank for deposits and withdrawals. They can't withhold your funds if you use a blockchain-based banking system. Insurance. I think insurance is one of the things that every single one of us has encountered one way or another, whether it's health insurance or vehicle insurance. If for example, if your car or something gets into an accident, and you have to claim insurance, you have to obviously bring the insurance people here, there to the accident site. They have to do a survey, and you will have quite a little bit of paperwork before you actually get the money. And more often than not, you don't get the money right away. You pay the money from your side, and then they like refund that money to your account, and that's how this works. But with if let's say that if a smart contract is doing all of that in an insurance situation, then you just have to take a couple of photos, take a couple of verification documents and things like that. Then you feed it to the smart contract, and there you have it. If you meet the criteria for the insurance, you are going to get your money. Healthcare is another important situation. I mean, a sector when it comes to smart contracts, because patient documentation and things related to documentation, especially, and patient history and things like that, those are kind of something that's kind of life and death. Because if you, let's say that you go to another country, and you get ill, and you are hospitalized, they have to know your previous history, your previous health history, to actually, diagnose you better if you have any kind of allergic reactions to, like, penicillin and antibiotics and things like that. So they have to know that before treating you, because otherwise things could go horribly wrong. And even in things like cancer research, cancer, and every kind of thing, in every kind of thing related to research and healthcare and patient data records keeping, I mean. And those things, blockchain and smart contracts are extremely important. I mean, can be extremely important. And even in the pharmaceutical industry, if it's like a pharmaceutical store that is selling you you know uh, medicines. What would happen is that a doctor, they would prescribe you some medicine, and you show this prescription to your local drugstore, or something like that, and they give you the medicine. But even those records are stored on normal centralized systems, and anybody can hinder that. So, drug seeking behavior and things like that can happen easily. But when it's done through a blockchain and through a smart contract, you can have something. It's infinite, because you can have something like a QR code. You can scan that, and the system already detects what kind of which doctor you've been to, and it already knows what kind of medication he has prescribed for looking at any prescription or anything. So everything can be digitized, and everything can be reliable, because it is stored on the blockchain and validated on the blockchain. So, apart from that, yeah, governance, like we spoke of before, the government is one of the biggest use cases for blockchain, because it is true that most governments today are not seamless in their functioning. Like, there are discrepancies here and there, and even in the developing and underdeveloped countries especially, there is a lot of room for corruption. And that is a truth that we have to realize. And blockchain, especially smart contracts, in this situation, in the field of governance, can change the whole game. For just a simple thing, even just a simple situation, like to get the ration, going to get the ration, going to get your checks in the sense, your welfare checks, for the backward communities, the financially backward communities. All of these things, if that is done through the smart contract, you don't need to, like, go behind, or you don't have to suffer at the whims of bureaucracy to get what you need. You don't have to have trust with the government to actually get things happening. These trustless systems, what they do is they eliminate the need for trust, because if you go to a ration store, or a government health store, or a government hospital, you know that you can show your identification. You can show your identification and feed it into the smart contract, and you can be sure that you will get what you need when you go there. And supply chain as well, that is another example. Any kind of supply chain, whether it be pharmaceuticals or groceries or whatever like that, at every stage of the supply chain, everything will be validated. Um, Everything can be recordically, I mean, it can be recorded properly, and you can verify it as well. And another thing with public blockchains, like Ethereum and Binance Smart Chain and Tron and Polkadot and whatever, the good thing with them is that on a public blockchain, anybody can validate any transaction. I mean, verify any transaction. If you have, let's say that if a government system, if a government, if just say that it is a road that they want to build, it is, or it is a hospital that they want to build. If they have a certain amount of money that is allotted, that they have allotted for the job, they can the smart contract can deal with that, and any person, any citizen can go to that portal, that blockchain explorer as we call it, and they can see what happens to the money. They can see exactly how much money is being allotted, how much money is being used, and every single thing related to that build can be verified on the blockchain. So, the use cases are absolutely infinite when it comes to blockchains. And token versus coin. Now, this is actually a smaller topic, and it is important because many people, these two words have been used, they have been used with each other for a long time. People reciprocate these words all of the time because it's kind of hard to understand what a coin is and what a token is. Because you can call a normal ERC20 token, for example, you can call that a coin. But the actual difference here is that a coin is related to a specific blockchain. Let's just say that Ethereum's coin is Ether. Bitcoin blockchain's coin is Bitcoin. But all of the other tokens under Ethereum, like let it be Chainlink or anything else, Chainlink, Uniswap, and there are a lot of tokens. So a coin is specific to a blockchain, and the major use case of that coin will be to facilitate transactions and payments that are specific to that blockchain, to the functioning of the blockchain. So we can say that a coin is the native currency of a blockchain. A token has unlimited use cases. When that coin, whereas a coin is just used for like payments and facilitating transactions on a blockchain, tokens can be used for multiple things. For example, the BNB coin, BNB coin, it is used to make payments, and Ethereum is used to make payments and also as mining rewards, and it works within the Ethereum blockchain. But where on the other hand, maybe tokens like Chainlink or Uniswap or other ERC20 tokens, whatever they may be, they actually serve a purpose within their specific ecosystem, whether it be for rewards like Uniswap has. It has governance features, it allows people to vote, and a token can do a token can be programmed to do a wide range of things within a single ecosystem. Whereas Ethereum is more of the native token, native currency, the native coin of the Ethereum blockchain, Ether. So that is what the difference. That is the difference between token and coin. Now, Ethereum Solidity contract. Now, the Ethereum is probably the biggest smart contract platform that we all know about, and Solidity is the programming language that Ethereum uses. And Ethereum, Binance Smart Chain, Tron, all of these blockchains, they use basically Solidity smart contracts. It uses Ethereum virtual machine, which basically means that you can code a smart contract in Solidity, and you can test it and run it on the Ethereum virtual machine, and it can be deployed on any blockchain. If you have a Solidity contract, if it's just a simple token that works like on the ERC20 token standard, you can deploy it on Ethereum, you can deploy it on Binance Smart Chain, and you can deploy it on Tron without any kind of change to the contract. More often than not, you can do that. Apart from that, if it works with multiple functions with multiple platforms and things like that, you might have to tweak a little bit here and there, but generally whatever you can do on Ethereum, whatever you can do on the Ethereum virtual machine, you can mostly do on these platforms. And even smart contract platforms like Polkadot, they support Ethereum virtual machine to an extent. And yes, the current issues. Now these issues are important because these issues are the reason that blockchain is not being, and the smart contracts are not being adopted by widely by anybody. Like, we all use cryptocurrencies today, we all use smart contract platforms today, most of us do. And even the government is trying out ways to include blockchain and smart contracts into the mix. But the reason for them not being widely accepted is because of these issues. Scalability is one. If you have if you have a software, if let's just say that Ethereum, if you have deployed a smart contract on Ethereum, there is a limit to what Ethereum can do, because there is a transaction speed limit. How many transaction? I mean, there is a transactions per second. I mean, how many transactions within a second can the Ethereum network process or validate? You cannot increase that. That is a fixed number, and if you have a bigger scale, a larger scale project, and that has millions of transactions coming in, it is impossible to have that working seamlessly, because there is a scalability issues. You cannot, whatever blockchain it may be, whether it be Ethereum, I mean the current second generation of blockchains, whether it be Ethereum or a Binance Smart Chain or Tron or any of the second generation smart contracts, I mean blockchains, you cannot add any extra features to it because it's a blockchain. You have to adjust with what it has already, and build your blockchains accordingly. So that, I mean, applications accordingly. So that's one of the things. Transaction speeds, there is, as we said, there is a limit to how many transactions that blockchain can process. And if it gets above that limit, then it's kind of like a queue situation where only another transaction cannot parallelly work together. So if we have 10 transactions, the first transaction has to go through, then the second transaction, then the third transaction, and that is how it works. Transaction costs, obviously. The validation process, something that we call mining, is what happens in the blockchain transactions. And in Ethereum, what happens is, if there are multiple transactions happening at a time, the validators or the miners only validate transactions that pay the highest gas fee, the transaction fee. So the costs can get fairly high. And now with proof of work algorithms, I mean blockchain, that is being solved, but still that is a problem. Interoperability. Now this is one of the biggest reasons that blockchains don't work well on all situations, but it's being mitigated with third generation of blockchains. But what interoperability is, the ability of a blockchain network to communicate with another network. Let's just say that there is Ethereum and there is Binance Smart Chain. If you have a decentralized application on Ethereum, you cannot directly communicate with Binance Smart Chain. You cannot send a token that is on Ethereum to Binance Smart Chain without some kind of intermediary. And we use bridges for that. Like, there is no way to send a token or data directly from a blockchain to another blockchain. You have to have some kind of intermediary, and usually that is facilitated through bridges, and even that is not perfect. If you send an Ethereum token, like an ERC20 token, from Ethereum network to the Binance Smart Chain network, what happens is you send that into the bridge holds the token, and it mints another like an entirely new token on the Binance Smart Chain with the same features and things like that. So it is not an exact it's not exactly interoperable. It is just, we just working around the things. So this becomes a problem when if Ethereum, since Ethereum gas fees are it's an example. Since Ethereum gas fees are so expensive, if you want to switch to Binance Smart Chain, either you have to build your application completely on Binance Smart Chain from scratch, or you have to use a bridge. And there is Okay, I think we have a few questions here. Um, okay, Ganesh in Dreamland. I'm sorry for interrupting. Interrupting my session. Hi, okay. Will the Dodge use Ethereum contracts? Is it possible if it uses, then will it improve transaction speed? Actually, okay, this is related to interoperability and scalability. Actually, Doge does not use Ethereum contracts because Dogecoin is not a smart contract platform. Dogecoin is more like Bitcoin. It is a peer-to-peer currency system and not a smart contract platform. So, I think the question is whether the Doge transactions will be even more fast. I mean, if the transaction speeds can be increased through Ethereum contracts. Or like Solidity contracts. That's not going to happen because if Dogecoin wants to use Ethereum contracts and if it wants to increase the transaction speeds considerably, it has to create a separate blockchain to do that. That's the whole point because you cannot add anything to a public blockchain after you've deployed it. You have to create a separate blockchain, and it's called a hard fork basically, because Bitcoin had a few issues in terms of transaction speeds and things like that. So they hard forked it. Somebody hard forked it into Litecoin, and that was even more even again hard forked into Bitcoin Cash and things like that. So that is not possible. Dogecoin cannot use Ethereum contracts, but what it can do, it can run on Ethereum blockchain using a bridge. Basically, it is not, like we said, it's not an exact interoperable solution. It's not an interoperability solution. What happens is you can send Dogecoin using a bridge to Ethereum and create an ERC20 token on Ethereum with the same features as Dogecoin, and hold the Dogecoin that you send on the bridge, and it can be interoperable. Basically, what happens is there is a bridge, and Dogecoin is the Dogecoin network is on one side, the Ethereum network is on the other side, and you send one Dogecoin or whatever it is to the bridge. The bridge creates an ERC20 token and it gives it to the Ethereum network, and you can use it there. It is possible, but it is not exactly a proper scalability solution, I would say. And interoperable blockchains, we do have interoperable blockchain with blockchains right now. Okay, we do have interoperable blockchains today. I mean, the third generation of blockchains. A good example would be Polkadot and Cosmos. Then there are other blockchains as well with multi-chain infrastructures. Usually for interoperability, what we have done, or at least not for interoperability, at least to solve the issues of transaction speeds and things like that for Ethereum, layer 2 solutions have been implemented, like Polygon Matic or and Plasma and things like that. What they do, like Harmony and things like that, what they actually do is they carry out transactions on a separate blockchain. What Matic does is they carry out transactions on their blockchain, like smart contracts on their blockchain, and they use Ethereum to store the end value. The end they store the transactions. The smart contracts run on Matic, and they store the data on Ethereum. This is not exactly a highly scalable solution because it still depends on Ethereum for all of it, and it is not completely within a single ecosystem. Ethereum and Matic are still separate. They are just connected as another layer. They're just adding another layer. But what interoperable blockchains do is that for example, Polkadot and Cosmos. Polkadot and Cosmos are revolutionary in the sense that they have changed the way we look at blockchains. If we look at Ethereum, if you want to scale Ethereum, you can use Matic network, meaning that you can run smart contracts on Matic and you can store the data on Ethereum and validate the transactions and things like that. You can use proof of work on Matic and don't have to worry about the transaction speeds on Ethereum. But still, these are two separate blockchains. With Polkadot, what Polkadot has done is that they have built a framework called Substrate, and it uses a programming language called Rust, and it also supports Solidity contracts. And you can build blockchains easily using Substrate and then connect it to Polkadot. Now, this is huge because, like we talked about before, if you want to send a token from Ethereum to Binance Smart Chain, you have to use a bridge, and that bridge has to be always online. And it is not an exact interoperability solution. It's not an exact solution to make two blockchains interoperable. With Polkadot, there is going to be, they have a central chain with, it's called a relay chain, and that central chain provides the security, and the decentralization and everything related to that. Everything that Polkadot offers, the central chain provides that, and you can create a separate blockchain on Substrate, on the framework Substrate, and connect it to Polkadot. And what that does is that if let's just say that the central chain is here, and if I have a blockchain related to supply chain, and I have a token, and there is another token related to, let's say anything, movies, whatever, and there is another blockchain on the Polkadot network. Like both of us created separate blockchains, and we connected it to Polkadot. I can send the tokens and data from my blockchain easily to the other blockchain because it is within the ecosystem. This is still in its early stages, I guess, and but this has opened up a world of possibilities in the field of blockchain, because this was not done before. This was not possible before. Two blockchains communicating with each other and being interoperable was not something that was in any way viable before. These multi-chain blockchains like Polkadot or Cosmos. And I'm sure that in the days to come, there will be even more blockchains that have interoperability, that will master interoperability. And so if for example, within the Polkadot ecosystem, two blockchains can communicate. But if you want to send a token or a data from Ethereum to Polkadot, you still need a bridge. You cannot directly send data from Ethereum to Polkadot. And I'm sure that the purpose of this webinar even is not to just introduce a topic in front of you guys. It's important to understand that every single person that has made these platforms possible, these blockchain possible, the technology remains the same. Actually, it's just a matter of creating a distributed ledger system and validating using cryptography and mining and things like that. The technology remains the same. It is how you use that technology, that how you make it better, how you polish it, how you create new mechanisms to make it even more seamless, that matters. So the purpose of this webinar even is to encourage everybody to think ahead and come up with your own ideas, your own systems. And just remember that every single person that has worked on these blockchains, on these technologies, has been like just people like you and me. It's just the difference is that they have dedicated their lives to something, and they have thought about something different, and it has worked out. And you can do the same as well. So let's see if we have any questions on the chat. I don't think we have at the moment. I don't think we have any other questions at the moment. If you guys have any questions, you can definitely ask in the comment section below, and I'll try my best to answer them. I think, yeah. Okay, yeah, Ganesh. I'm happy that I could answer your question, and I think that is it. And thanks, guys, for joining us. And even if you have any other questions, we're going to be winding up right now. But even if you have any other questions related to blockchains or smart contracts or whatever, you can DM us on our social media profiles. You can comment down below on this video. This live is going to be posted on YouTube, and you can most of you are going to be viewing it afterwards, I guess. So you can just comment down below, and we'll get back to you. We'll try to answer as many questions as possible. And you can even comment down below what you guys want us to answer next, what you guys want us to cover next. And I hope that this was educational for you guys.